Hi, welcome to the video on text and image compression methods used for the data in multimedia communication or for the transmission of data in communication channels, which is a multimedia information. The video is all about the different text and image compression methods or the compression principles. Before we learn about the different text and image compression methods, let us first analyze about the compression principles that has to be followed at uh, that is the source encoder and destination encoders, the lossless and lossy compression, entropy encoding and source encoding. Always prior to the transmission of the data from source to the destination, the source information relating to the particular multimedia application, a compression algorithm is applied to it. In order for the destination to reproduce the original source information, where in some instances a nearly exact copy of the transmitted signal matches the decompression algorithm which is applied to it. So the application of the compression algorithm must be carried is required to carry it out by the source encoder, and the decompression algorithm is carried out by the destination decoder. In applications which involve two computers communicating with each other, the time required to perform the compression and decompression algorithms is not always critical. So both algorithms are normally implemented in software within two components. Coming for the lossless and lossy compression methods, the compression algorithms can be classified as being either lossless or lossy. In case of a lossless compression algorithm, the aim is to reduce the amount of source information to be transmitted in such a way that when the compression information is decompressed, there is no loss of information. The lossless compression is said to be reversible. For example, the application of lossless compression is for the transfer over a network of a text file, since in such application it is normally imperative that no part of the source information is lost during either the compression or the decompression operations. In contrast to this, the aim of lossy compression algorithms is normally not to reproduce an exact copy of the source information after decompression, but rather a version of it which is perceived by the recipient as a true copy. So in general, with such algorithms, the higher the level of compression, in general, with such algorithms, the higher the level of compression being applied to the source information, the more approximate the received version of the content will become. So, for an example, application of lossy compression are for the transfer of digitized images and audio and video streams. In such case, the sensitivity of the human eye or ear is such that any fine details that may be missing from the original source signal after decompression are not detectable. Next, about entropy and encoding. So, the different methods of text compression. The different methods of text, the three different types of text, unformatted text, formatted text, and hypertext, are all represented as strings of characters selected to form a defined set of data. So, in text compression methods, there are two types of statistical encoding methods which are used with text, one which uses single characters as the basics of deriving an optimum set of code words, and the other which uses variable length strings of characters. Two examples are Hoffman and arithmetic coding algorithms. So coming for the first one, which is static Hoffman coding. With static Hoffman coding, the character string to be transmitted is first analyzed and the character types and the relative frequencies determined. The coding operation involves creating an unbalanced tree with some branches, and hence code words in practice are shorter than others. So the degree of imbalance is a function of the relative function of frequency of occurrence of the characters. The larger the spread, the more unbalanced is the tree. So the resulting tree is known as Hoffman code tree. The Hoffman code. Hoffman code is a binary tree with branches assigned the value of 0 or 1. Where the base of the tree, normally the geometric top in practice, is known as root node, and the point at which the node divides a branch node. So the different Hoffman coding methods are followed. So here, as each branch divides, a binary value of 0 or 1 is assigned to each new branch where it takes over. So the other text compression methods are image compression methods we have. In image compression, the different formats of image compression are graphics interface format, tagged image file format, digitized documents, and JPEG format. We'll try to understand about this one after the other. The different compression principles. So the image compression principles. In image compression, the main intention is by compression, the volume of the information to be transmitted can be reduced. At the same time, the reduced bandwidth can also be used. So the application of the compression algorithm is the main function carried out by the encoder, and the decompression algorithm is carried out by the destination decoder. So here we have a block diagram which shows the compression process. Here we can see that at the source computer we have the source information, a source encoder programmer, and then the data is transferred over the network, and at the destination computer the destination decoder program will be executed and the copy of the source information is transmitted. So coming for the compression algorithms. The compression algorithms are classified either as lossless or lossy algorithm. The lossless algorithms are followed to reduce the amount of source information to be transmitted with no loss of information. For example, transfer of text file over the network, whereas in lossy compression method, it is a nothing but reproduction of a version perceived by the recipient as a true copy. Few examples are digitized images, audio and video streams. So entropy encoding and run length encoding lossless. These are the two methods to compress the image or the text to be a lossless information. So here we have the different types of mode. For example, if we are taking an example of a run length encoding, where the source information compresses long substrings of the same character or binary digit. In this, the source string is transmitted as a different set of code words which indicates only the character but also the number of bits in this substring. Thus, by providing the destination knows that the set of code words being used is simply interprets each code word received and the output approximate number of characters per bit. For example, a fax machine. Entropy encoding, it is one of the statistical encoding methods. Here a set of ASCII code words are often used for the transmission of strings of characters. However, the symbols and the code words in the source information will not occur due to Z frequency. So, the statistical coding uses the property by using a set of variable length code words, where the shortest being one representing the most frequently appearing symbol. The next type of encoding is differential encoding. In differential encoding, we make use of smaller code words for representing the different signals. It can be either a lossy signal or a lossless signal. And this type of coding is used where the amplitude of the signal covers a large amount, but the difference part between successive values is very less. So instead of using large code words, a set of smaller code words representing only the difference in amplitude can be utilized. For example, if the digitization of the analog signal requires 12 bits and the different signal requires only 3 bits, then there is a saving of 75% on transmission bandwidth. So we need to select a smaller code word rather than larger code word. So the compression principles. Here it shows the diagram of a pixel pattern. Here the transformer encoding is involved. The transformer encoding is involved for while transferring the source information from one form into another form. The other form will be lending itself more readily to the application of the compression. Here, during the compression of an image or a text, the pixels pattern and the pixel amplitude and the pixel count is very much important. In this diagram, we have a pixel pattern where we can see the pattern varies, and this is a pixel amplitude that is fixed, and it has a low spatial frequency, and one more is high spatial frequency. The low frequency signals and the high frequency signals are treated separately in the compression principles. Next, coming for transform encoding. In transform encoding, a set of pixel locations that changes the rate of change in magnitude and leads to the vary of the signal from 0 if all the pixel values remain the same at a lower rate of change is one off and the next off through a high rate of change. So the rate of change in magnitude as one transposes the matrix gives rise to a term known as the spatial frequency. So here, by identifying and eliminating the higher frequency components, the volume of the information transmitted can be reduced. So a discrete cosine transformation is used to transform a two-dimensional matrix of pixel values into an equivalent matrix of spatial frequency components. At this point, any frequency component with amplitudes below the threshold values can be dropped easily, so which leads to a lossy transmission. This diagram shows the 2D matrix of the pixel values, which represents the discrete cosine transform values. Next, coming for Hoffman coding. An Hoffman coding is a method of constructing for an encoding tree where it consists of a full binary tree representation, and each edge of the tree will have a value where 0 is for the left and 1 is for the right. And here the data is at the leaves and not internal nodes, which results in an encoding tree. And this Hoffman algorithm will finally result in a variable length encoding process. In Hoffman algorithm, the three main important constraints are to maintain a forest of trees, and weighing of the tree, which should be equal to some frequency of the leaves, and the node should be 0 to n minus 1. So we need to select two smallest weight trees and form a new tree while branching out. In Hoffman coding, a variable length code whose length is inversely proportional to that character's frequency shall be selected and must satisfy non-prefix property to be uniquely decodable. So the two-pass algorithm for the Hoffman coding is: first, pass accumulates the character's frequency and generate codebook, and secondly, the second pass does compression with the codebook. So the Hoffman code creates codes by constructing a binary tree where we consider all the characters of free nodes assigned to free nodes with lowest frequency to a parent node with weights equal to the sum of their frequency, and after that we'll remove the two free nodes and add the newly created parent node to the list of free nodes. Next, we'll be repeating the same steps until there is one free node left, which becomes the root of the tree. The Hoffman coding method is nothing but the narrowing down method where we arrive at the base level. So this is one of the example for the Hoffman coding. So this is one of the example where we can see the tree formation that is done in Hoffman. So we also have static Hoffman coding process where the signal is static. Here we can see that this is a root node, the branch node and the leaf node where the symbol occurs with the frequencies.